So let me kick off. So let me just quickly, for any last minute stragglers there that join the call, just to reiterate, as the slide says in front of you, please keep cameras off and microphones muted during the webinar. Q&A will be at the back end, but please get any questions you've got throughout the presentation, get them in the chat, and we'll address them. And any that we can't, we'll pick up and respond offline to you on those. Right, get straight in. So agenda, we've got a really packed agenda in this 60 minutes, so it needs to be really succinct. I'm going to kick off and I'm going to give you an overview of the new Net Zero Transition Panel that the Guild's implemented in the last sort of 6 months, but it's been something that I've been working on with the Guild for at least 12 months, from a concept and then implementation and development of that structure, and now it's fully embedded into the Guild, and this is our first webinar as a panel. So I'm going to give you a bit of an overview of what our vision is. We're then going to go on to business carbon footprint and reporting, and that'll be Hannah, who's an environmental advisor from Cadent. Then into Burwell AGI rebuild and Cadent's 10-point plan, which Chris Packwood from Cadent, who's a project delivery engineer within the capital delivery team, he will give you oversight and overview of that. And then we're going to go into some more of the detail around that project from Murphy, around actually the carbon life cycle assessment that they've been working on, and that'll be from Zach, who's a senior mechanical engineer from Murphy. And then we're going to finish off at the tail end from Nathan Reed, Director of Applied Engineering from Murphy, and we're going to look in a bit more detail around their sustainability journey and some tools that they've implemented into their business, and share some really interesting insight into the cost and environmental impact and savings that they're bringing to the industry. That's the agenda for today. So moving on, so in my day job, I'm a project director at Cadent. My role in Cadent fundamentally is I'm involved in developing the high pressure transmission hydrogen networks of the future. I'm covering the east of England and North London networks for Cadent, and that is fundamentally looking at connecting and decarbonising industry. So alongside that, I'm the panel chair for the new Net Zero Transition Panel, properly kicked off in January this year. We've got a great host of events and information coming out across our roadmap for the next 12 months, which I'm going to touch on a little bit. So our vision, really quite simple and clean, really. What we've set out is 5 lenses or pillars to what we look at in the panel. Sorry. There's 5 lenses within the panel that we're looking at. The fundamental driver here is, as a panel, is to bring together the communities that we've got from existing networks and industry professionals, and we're informing, discussing, and using that to implement practices, shared learning between industry. Now, what underpins our vision there is a product we've been developing for around 6 months with Scoob, and this is going to be an online hub, which will be a shared library repository of all net zero content across these pillars. So depending what sector you're in and what part of the value chain and what you're interested across these lenses of net zero, you should be able to navigate within 2-3 clicks to some very specific content around that net zero, to help you understand where your pathway and where you fit in within that journey, what learning's out there, and try and get some focused content and material. I think there's many sort of social platforms, and you go on there and it's quite noisy. It's quite hard to, what should I be reading? What's opinion? So it's to try and create a really clear, simple space for people to be able to navigate and understand what's going on in the net zero sort of transition and pathway within our industry. So that's our vision. That's a nice segue now This is our first webinar and we're focusing on the lens of net zero construction. And to that end, I will pass you on to Hannah.
So hi everyone, good afternoon. My name is Hannah and I'm an environmental advisor here at Cadent Gas, and I'm going to speak to you today about business carbon footprint and how we approach this at Cadent. So if we can go to the next slide. So what is business carbon footprint? Business carbon footprint is a measure of all the greenhouse gas emissions that are related to a business and their activities. So this can be emissions directly created by a business, but also indirectly created by the business's activities. So Cadent uses the Greenhouse Gas Protocol standards and guidance to measure and then report our greenhouse gas emissions. And the protocol has defined 3 different scopes for reporting purposes, so we can distinguish between those direct and indirect emissions. So Scope 1 emissions are those that are created from sources that Cadent directly control, or any other business. For example, commercial vehicles. Cadent own their own vehicles, they use these vehicles, and then the emissions that are created are a direct result of Cadent's activities. Other examples include emissions from the boilers that we use in our offices and emissions that come from company car use, things like that. But at Cadent, shrinkage has the biggest impact on our Scope 1 emission data. So this is loss of gas through theft, which is quite difficult for us to control. So we find it quite difficult and challenging, but make great changes on our Scope 1 emissions. Scope 2 is less complex. This covers indirect emissions from the generation of purchased electricity. And so in Cadent, this is purely the electricity that we purchase. And then Scope 3 is all other emissions that are indirectly produced as a result of the company's actions. So this covers emissions that are not directly produced by the company or their assets, and everything else that isn't really covered in Scope 1 and 2. So here at Cadent, this will cover any air or train travel, hire cars, P-pipe, contracted commercial vehicles, private vehicles, and very nichely helicopter aerial surveys. These Scope 3 emissions are direct result of Cadent's functioning, but Cadent don't have direct control over the production. So in the same manufacturing company, Scope 3 emissions will include the emissions from sold products. But because of this, procurement is the starting point for us to reduce these emissions. And the scale of Scope 3 means it can be difficult and time-consuming to calculate. In our experience, most companies try and establish reasonable limits on what Scope 3 items they can calculate and control. So links with the supply chain are extremely vital in reducing these Scope 3 emissions. If we go on to the next slide, please. So this is a visual representation of the way in which the scopes are broken down. So it shows where your upstream and downstream activities fall into the scopes and highlights some of the key activities that can produce emissions within these scopes. But just to kind of clarify a bit more, the difference between Scope 1 and Scope 2 is that in Scope 1, you directly use, say, gas and release these emissions, whereas in Scope 2, the emissions have already been generated in the production of, say, electricity. So Scope 1, we get the fuel, we use the fuel to make energy and then use this energy, whereas in Scope 2, we get the energy directly. So on to the next slide, please. But why do we measure business carbon footprint? Well, at Cadent, we have this as a requirement from Ofgem. However, we use it as beneficial to track our emissions over time and help us set achievable targets. The tracking of the data can show key areas that require investment or improvement and help us reach net zero targets. The data can also be required by any external stakeholders and investors. But when presenting a business carbon footprint figure, this data is always expressed as CO2e, carbon dioxide equivalent. And this figure is used to describe the impact of 6 key greenhouse gases: carbon dioxide, methane, nitrous oxide, sulfur hexafluoride, perfluorocarbons and hydrofluorocarbons, a bit of a mouthful. But by converting all of these emissions to CO2 equivalent, you can showcase the overall global warming potential with just one figure. So to turn your raw data into these carbon equivalent figures, conversions are required. So here at Cadent, we use the UK DEFRA conversion factors, and these are conversion factors that are updated annually to make sure that they're still relevant and accurate. So for example, you could use one of these conversion factors to convert the kilowatt hours of electricity used to a CO2 equivalent figure to be used in your business carbon footprint calculation. So once all of your emission figures are in CO2 equivalent format, the total carbon dioxide equivalent figure can be calculated. And this is your total business carbon footprint, which you can see at the bottom. That is Cadent's figure. Next slide, if you can. So how can business carbon footprint be used to measure performance to net zero? Well, as we all know, the UK government has set a target of reaching net zero greenhouse gas emissions by 2050. But what's net zero? Well, net zero will mean that total UK greenhouse gas emissions will be equal to or less than the emissions the UK removes from the environment. The aim to do this is to both reduce production of emissions and then remove any unnecessary emissions that we create. Using our business carbon footprint figure allows Cadent and other businesses to monitor their carbon reductions on the way to net zero. So we can look at the speed of our reduction and then highlight areas where we need to improve to be able to reach this net zero target of 2050. So what are Cadent doing? Cadent are committed to becoming net zero by 2050, and the business has split their net zero strategy into 3 parts. So the first, decarbonising our business operations, secondly, reducing our environmental impact, and thirdly, facilitating low emissions energy system transition. So the steps Cadent have taken to reduce so far include exclusively procuring 100% certified renewable gas and electricity, moving to our new custom-built head office in Anstey Park, where we were able to incorporate key sustainable materials and technology to improve our environmental impact. So this included solar panels on the roof that generate up to 300,000 kilowatt hours a year of electricity, many electrical car charging points, living walls to improve our biodiversity, and much more. So this building has played a huge role on our route to net zero, and hopefully these technologies will continue to be rolled out among our assets. But the nature and scale of our business managing 5 key gas networks across the UK means Cadent release large volumes of emission due to their transport and their travel. So looking to reduce our travel emissions, Cadent have pledged 1,000 zero-emission vehicles to be included in our fleet by 2026. And this will visibly reduce our Scope 1 emissions. Alongside changes in our fleet, we've got a new company car policy, which has been implemented that includes a fully electric scheme. A part of Cadent's work is to change our old cast iron pipes to new PE plastic pipes to carry gas around our network. Our procurement team are working directly with suppliers to reduce the carbon emissions of the PE pipes that we purchased. As this is part of our Scope 3 emissions, communication with suppliers is key in working to reduce their emissions, and without these stable relationships developed by the procurement team, Scope 3 emissions would prove really difficult to reduce. However, in order to reach Cadent's and the government's target of 2050 net zero, using hydrogen as a fuel source will play a huge role. Alongside partners, Cadent have developed the HyNet scheme, the UK's first leading industrial decarbonisation project that aims to bring locally produced low carbon hydrogen as a fuel source to the northwest. We currently have a hydrogen experience centre in Whitby to demonstrate how hydrogen can be used in daily life for heating, cooking and hot water, and I would definitely recommend a visit if you're up in the area. As we look to the future, a hydrogen network will be a huge step in reducing the UK's greenhouse gas emissions. So as you can see, this is a really exciting time at Cadent. We've got so many sustainable initiatives in place and coming into the future to reach net zero by 2050. So I'll now hand over to Chris Packwood.
Thank you very much for that, Hannah. Good afternoon, everybody. My name's Chris Packwood. I'm a project delivery engineer at Cadent. And I'm here to introduce you to the Burwell AGI rebuild, Cadent's first net zero construction site. So for this project, we partnered with Murphy Applied Engineering, and I'm going to hand over to Zach shortly to run through the detail of the project. Just quickly before we press on, I just thought it'd be worth sort of briefly describing the purpose of an AGI. We operate a gas network that takes gas from the National Gas's transmission system, and we have a series of above ground installations that take that gas and get reduce the pressure right down to pressures that we see at our meters, our houses, homes and businesses. And to do that, Burwell is somewhere in the middle of that process from National Gas to your home, and Zach is going to go into the details shortly. But following on from Hannah's presentation around Cadent's ambition, as you can see on the right hand side of the screen there, that is Cadent's hydrogen 10-point plan. And number 1 of Cadent's 10-point plan is actually to deliver a net zero construction site. and Burwell has been firmly named as that construction site. So I think that teased that up nicely, short and sweet, and I'll hand you over to Zach to run through the detail and the design process that we've been through so far.
Thanks, Chris, for that. Afternoon all, thanks for attending this webinar. So my name is Zach and I was Murphy's lead design engineer for this project. So I'll start by giving a brief intro into the process elements of the site, and then I'll define what a conventional rebuild would consider, and then how we would quantify it. And then the main focus of my section would be to cover the various design alternatives that we proposed. And then finally, I'll summarize the overall projected reductions in emissions that could be made. So you can see on the screen here a model of Burwell. The site itself has got a high pressure inlet with three outlets. So two of them are high pressure and then one is intermediate. And typically for a natural gas AGI, we've got filters to get rid of any particulates that the gas may have picked up getting to the site. And then we have a preheating unit, which will preheat the gas before it undergoes pressure reduction. And then we have two pressure reduction streams as the main site assets. So one of the pressure reduction streams is currently redundant, so there's a temporary skid put in place. And the objective of this site was to kind of rationalize all the equipment, removing anything that was redundant and replacing it with permanent fixtures, whilst considering low carbon alternative materials, equipment, and looking at construction and then the operation of the site as well. Next slide, please. So to determine where the potential areas of improvements are, the first step was to conduct a baseline assessment. So that essentially covers a conventional design and build if we weren't looking at understanding what the emissions or where the emissions were coming from. So typically describe that as business as usual. And in order to quantify that baseline, we needed to gather a lot of data. So that data was coming from material quantities, how energy was used on the site, so the operational energy, and then looking at the construction activities and the timeframes involved in carrying out the build. So that typically included a natural gas powered boiler house for preheating, using diesel plants for construction, and then standard construction materials, standard mixes of concrete, steel rebar, virgin granular fill. So then all of this data was then put into a life cycle assessment tool, which resulted in whole life carbon emissions of around 1,900 tons of CO2 for a conventional rebuild. So that's over a 40-year design life. I've just got on the bottom of the slide a little definition of what whole life carbon actually means. So it's the sum of embodied carbon and the sum of operational carbon. So when we talk about embodied carbon, what we mean is everything involved in gathering the materials to build the asset, how we maintain the asset, and then how we what is carried out in the end of life of that asset. So deconstruction, waste processing, and then operational carbon that looks at any kind of carbon that is emitted through the operational use of the site. So that typically involves if there's any energy usage or water consumption. So in this case, you can see on the pie chart there, the operational energy use was around 85%, and that was down to using a natural gas fired boiler house for preheating. So naturally, that became the first area of focus in providing alternative designs. Next slide, please. So from that baseline model, we looked to identify four key areas that needed to be addressed. So these included alternative preheat technologies, the integration of renewable energy. So these two were to address the operational energy consumption. Then we looked at alternative plant fuels to address construction activities. And the final area was to look at low carbon materials to address embodied carbon emissions. Next slide, please. So we explored different energy carriers to move away from burning natural gas as a means to provide preheat. So this included hydrogen, direct electricity, and a hybrid of the two through fuel cells. However, we kind of moved away from hydrogen given the challenges faced with current technology. So boilers, for example, that there weren't any commercially available for the duty that we needed on this site. There was also the uncertainty of securing green hydrogen, and given the fact that hydrogen isn't flowing through pipes at this stage, there were challenges in terms of delivering hydrogen to site in canisters and loading that into the system. So this added a lot of complexity around integrating hydrogen into the site for a site that is typically unmanned. Direct electric heaters, they were a safe choice as it's been used before. However, to really maximize efficiencies, a ground source heat pump system came out on top. So whilst that's not really new technology, it is new in the application. So using it on an AGI is fairly new. And moving heat from one source to another proved to require the least amount of input. So that provided a 53% reduction in emissions, saving just over 1,000 tons of CO2. So after electrifying the preheat, the site's annual electricity consumption increased. So in order to mitigate that increase, we looked to deploy renewable energies on site. So this assessment compared solar panels only to wind turbines only to then a hybrid option in order to minimize the surplus and deficit energies you usually experience with renewables. So for the solar only system, this option proved to be quite challenging because its energy production negatively correlated with the demand for preheat. So for example, in the summer where there's a lot of sun, there's no preheating would be required. But in the winter, when there's high demand for preheat, typically you'd have low outputs for electrical energy, and this is typical across the daily load profile as well. And then looking at the wind only option, it was actually the most optimal, correlating very closely with the annual preheating trend. However, given the availability of the turbine sizes, the best way of meeting the energy demand and reducing the surplus and deficits that you experience would typically be a hybrid option. So this further cut the emissions by 350 tons of CO2. And to deploy this technology, we would need to look at installing it in the surrounding land around the site. So you can see on the left-hand side there, there's a plan view of what the typical areas that are needed in order to deploy this tech. Next slide, please. So the next area that we looked at was construction activities. So that's usually defined by fuel consumption. So similarly to the preheating technology, we looked at both electric and hydrogen plants. And at this stage, they were deemed unfeasible. For electric, the required capacities weren't commercially available, and then for hydrogen, similar to the boilers and the fuel cell, there was a bit of uncertainty with ensuring a consistent supply of green hydrogen. And whilst we did deem it unfeasible during the feasibility study, these options could be viable in the future. However, as a short-term solution, the switch from diesel to hydrotreated vegetable oil allowed us to achieve 90% reduction in emissions. So this was great because we can use HVO within our existing fleet without any modifications. So it became quite an easy win. So Murphy have also have other offerings within their green plant fleet to reduce reliance on fossil fuel powered equipment as well, which Nathan will cover later on. And overall, by switching to HVO, we managed to reduce a further 240 tons of CO2. Next slide, please. And then the last area of focus was for the materials involved. So given the limited availability of low carbon mechanical materials, more focus was actually placed on the civil elements, such as concrete, rebar, aggregates, and we carefully selected sustainable alternatives such as earth-friendly concrete, which contains zero cement and has been used on major projects such as London Power Tunnels 2. Again, Nathan will go into a little bit more detail around that shortly. Other elements such as glass reinforced plastic rebar to replace traditional steel rebar, it's an option that we want to explore further, given the fact that it's much more resistant to corrosion, 75% lighter, uses 50% less energy for transport and assembly. And then finally, we looked at recycled aggregates for backfill as well, in order to replace virgin materials and eliminate the need for quarrying. So this in total all offered a further reduction of 10 tons of CO2. Next slide, please. So to reiterate, we highlighted 4 areas to focus on. We conducted life cycle assessments offering varying levels of savings by proposing a bunch of different alternative technologies, materials, and if we proceeded with each proposal, we could save a total of 1,600 tons of CO2 carrying out this site rebuild. So that's around an 85% reduction that could be achieved with technologies that are available in today's market. Next slide, please. And you're probably all kind of wondering, what does 1,600 tons of CO2 actually look like? So to make it a bit more relatable, we could think about it in terms of heating just under 700 homes through renewable methods, or the amount of carbon required to build 25 new homes, or taking 1,000 cars off the road for a whole year. So we're due to start the conceptual design with the aim to provide further accuracy in the life cycle assessment, and then further progress with the net zero packages that we've got that we have in this design. So that's the heat pump system, the renewable energy center. So we're going to look to further develop those together. And I think that's it. So thank you for listening. Hopefully it was insightful and I managed to get across the significance of LCAs in guiding front-end design. Yeah, thank you. I'll hand it over to Nathan now.
Hi everyone, how are you doing? I'm Nathan Reed. I look after the Murphy Applied Engineering team within Murphy. I'm also leading the Net Zero Construction Lens as part of the Net Zero Transition panel with Adam and his team. So I'm here to talk about our journey towards net zero. Zach talked about how we're reducing carbon during the design phase, but also I just want to talk around some of the considerations during the construction phase as well. Okay. I guess it starts with this feedback on the call there. Sorry, thank you. It starts with our roadmap as well. Obviously, Cadent's one of our big clients, and we sort of follow in their footsteps in certain areas. And Hannah sort of talked about the Cadent roadmap. We're at Murphy's. We have a Murphy roadmap as well, and we sort of sat down in 2021. Our sustainability team pulled together, where we want to be. And I just thought I'd highlight some of the points along the road and some of the key things that we're looking at, and just to share with you what we've been looking at, where we found successes on, to sort of share the knowledge really, and to share our learnings, and hopefully others can do the same. So one of our key targets is at 2026, which is our Murphy at 75 anniversary, or 75-year anniversary. We are looking to have 50% emissions reduction for operational emissions. And then the next key point in the road is 2030. We are aiming to be net zero for all operational emissions, which is a very aggressive target for a construction company. But it's just, I thought I'd hit some of the things that we've been doing and what we've been finding as well along that road. So we're using, we realize that I think for scope 1 and scope 2, it's a bit easier for us to control. So Hannah talked about the different scopes in Cadent's business, and we're not dissimilar to Cadent in that respect. Scope 3 is a bit more difficult. So we're really now using our procurement team to understand not just our own emissions, but our suppliers' emissions, our subcontractors' emissions, and getting them to work with us and bringing them along the similar journey as well. So there's a big piece of work being done in the background to move things forward. We've already got a green procurement guide that allows us to choose more sustainable and low carbon materials. And going forward, we're moving and working with our big suppliers, or having them bring us along, like some of the bigger suppliers, or us bringing some of the smaller ones along, the similar sort of journey. We're also in certain other areas between now and 2030. We've found some, big benefits in changing tariffs to renewable energy. We're working with HBO after a little bit of a supply shortage last year, but we've managed to get a good supply, and we're pushing that now through 2023. We're the last few years as well, we've seen almost like a cultural change within our business, and people engaging with this roadmap and moving things forward as well, specifically on projects themselves, and making their own initiatives, working with clients. Clients are moving along with us as well, and moving new initiatives, new innovations towards a lower carbon future. If we just move on to the next slide, please. So one of the other things that we've implemented is a carbon calculator, or a sustainability tool. We call it the Murphy Carbon Calculator. Basically, Zach showed that you could baseline carbon information during the design phase, but what we need to do is also measure to track our performance against the design, or the estimate of what we expected our carbon footprint to be on the project. So we've got this tool that's available. It's sort of cloud-based, and we've only just rolled it out, to be honest with you. So it's aligned with government reporting protocols, and we've started now getting project data uploaded into this cloud-based tool, which allows us to understand our impact of the decisions that we make on the project, and we can see how a project is tracking against the baseline that we've agreed either amongst ourselves or with the client as well, to ensure that we hit the targets around the carbon reduction that we originally agreed during the design phase. It also has functionality to make high-level engineering decisions as well. So it's got a carbon calculator. It's got embedded embodied carbon information for a variety of materials as well. And if we move on to the next slide, Adam, we have a number of issues that we report on. So fossil fuel usage is obviously one of the biggest ways that we can reduce our carbon footprint on any project. So we report on that, as well as a number of other points. So for the majority of scope 1 and 2 emissions, that we can capture that information and report on that per project. It allows the project to see us how we're traveling monthly, and allows our executive level to see how each project's going as well. And also we can also get scope 3 information from our supply chain and include that in the reporting as well. So we can really build a big picture of how our projects are operating and the impact of our decisions from a carbon perspective. So if we move on to the next slide, one of the key parts of our business is obviously plant, and we've implemented these hush pods, which I think, to be honest with you, they're called hush because they're quiet, they're silent. Basically, they're a lithium-ion battery bank that we connect to generators, and then acts as a power storage, and kind of just buffers the power that the generators are generating, such that the generators don't work when they don't need to, so they're not operating 24/7. And we've started logging the data associated with these hush pods. Specifically here in this case, we've logged it on a Sophia, which is a cable installation project, a linear cable project. So I think it's about 10 kilometers worth of cable. And over the 49 weeks, we've saved 47,000 pounds worth of diesel. And overall, if you include the additional hire rate for the battery pod, it's still £25,000 saving. That's $1 saving for going greener, and the obviously the savings there you can see yourselves, 82,000 kilos of CO2, and that's just one specific project. So if we move on to the next slide, Adam, we've actually logged the data now for all the hush pods across Murphy's and all the projects. Now the usage is actually growing up because people are realizing that A, you save money, and B, we have A, you save money, B, you can also have a carbon impact. So total for the year between June 22 and May 23, from when the figures that I have here, we've saved almost £500,000 worth of diesel, and we, you know, £1,000 of CO2. If we put that into perspective on the next slide, please, that is using Zach's calculations. I've stolen this slide. 430 households or 630 annual travel for vehicles. So this is a significant saving that we've had on top of cost savings by using a new bit of equipment that's a bit more innovative. It stops the generators from running. We've also, to be honest with you, also changed our habits a little bit on the sites as well. You know, we turn off air conditioning or heating during the evenings when it's not needed. We ensure that all the doors and windows are closed, that sort of thing. So it's sort of driving good behaviours and to look at saving carbon across the business. So because of these, it's also almost a no-brainer. We're basically mandating the use of these pods on all 40 kVA generating sets as well across the business. What I would like to do as well is to share this case study on the portal that Adam mentioned earlier on, as well as some of the others that we'll be talking about too. But I think this is a really good one for other businesses to take up. If we move on to the next slide, so the last thing I just wanted to talk about was materials. So we talked about plant, we talked about design. One of the other things is materials itself as well. So on another project, on the LPT2 project that Zach mentioned, it's a JV between Murphy and Hockteeth for National Grid Electric. So it's a London Power Tunnels. It's a cable tunnel across South London. We've been working for a number of years with AECOM and National Grid as well on trying to test and to utilise this low carbon concrete. There are other low carbon concrete mixes available, but there are I think there are only two available that are cement free. So there's one called CEM free, and the one that we've used here is called EFC, earth friendly concrete. These are both called AACMs, alkali activated cementation materials, and they have zero cement within them. The great thing about this material is typically, depending on what type of concrete you're comparing it to, but you could save up to 200 kilos of CO2 equivalent per cubic meter of concrete, and so roughly about a ton of CO2 equivalent per load. Because these are have no cement at all, they're a little bit outside the standard. So we did a lot of testing with National Grid to ensure that they were usable and suitable. Initially used it on temporary works applications, but now we've done, as you can see on the slide here, the world's biggest cement-free pour in a permanent works application. Basically, it's a base of a tunnel, a shaft. So against other low cement mixes, it's an 80 ton of CO2 equivalent saving using this pour. Against higher cement mixes, it's a much higher saving, you know, up to about 200 tons. So for me, this is a really good use of new technology that's available. There's other benefits of this, which if people want to go in the Q&A, I can talk about as well. Benefits of using this concrete, and National Grid are really happy with the results so far. So we're working with them to move this through on other projects as well within our business and with everybody else. So that's all I have for you. Thanks for your time, and we'll move on to Q&A. Adam, I think you're chairing that one.
Yeah, thank you, Nathan. So it's probably useful at this point if Nathan, Hannah and Zach, if we all just, and Chris, if we just keep our cameras on, and then we'll try and direct Q&A. I'll try and facilitate that the best way that I can. So let me just open up the chat here, have a look at what we've got, see if we can direct it. Okay. Well, I've got one here from Phil Croft. What would the whole life cost comparisons between the business as usual solutions versus the alternative solutions? Right. Okay. I think that's probably something, looking specifically at that, Phil, whether you can come off mute, Phil, if you want, and expand on that question a little bit more around the specifics of that. So
yeah, sure. Thanks, yeah, it was about the Burwell AGI, I think, feasibility study, wasn't it? It's not at conceptual design yet, so it's just whether we'd actually about the various solutions when we were selecting them.
Yeah, I can probably take that one. You broke up slightly, Phil. So considering we're at feasibility, how we're looking at the whole life going forward and the decisions on the type of equipment, was that about it?
Yeah, just so traditionally it would have been gas preheat, and that would have had a cost. Yeah. And it, as that worked through the solution for ground source heat to ground source preheat, and I wondered whether you managed to even get a relative, even if it's approximate, cost of that solution and some of the others that you mentioned as well.
Sure, fine. So I was again confused between cost of carbon cost and actual cost. So you're referring to actual cost in monetary terms? Yeah.
Pound notes, yeah, pounds.
Yes, yeah, fine. So we haven't got that far. We've started engaging suppliers for some sort of consultancy into get more information about the technologies. We're not at a point where we're receiving cost estimates or quotations yet. For the ground source heat pump package, if you like, we're not anticipating any huge changes in cost from a traditional boiler package. I mean, the units are sort of washing machine sized, as we know and love our boiler packages, and it will probably come in a similar sort of setup as a traditional boiler package in a house that's sort of boiler house or ground source heat pump house that's manufactured off site and is dropped on. The key difference in the cost will come when we get into the detail of the vertical boreholes. So there's two options to go vertically downwards, approximately 100 meters, give or take 20 meters, or it would take a huge amount of land to go horizontally, a trench maybe 1.2 meters deep. So the only feasible option here is to go down vertically, and that's going to be a challenge, and that's one of the big things that we're hitting first up in the conceptual design. And there's a lot of sort of process engineering combined with geotechnical engineering to determine things like thermal resistivity and a number of other factors that I'm not going to try and reel off now because I'll get them wrong. But yeah, so we're getting to it. With regards to hydrogen, we sort of engaged hydrogen boilers. This is for preheat. We engaged the supply chain, and it wasn't quite ready at the scale we required to actually procure the hydrogen boilers. And then we had another huge challenge of where we get the hydrogen from and how we supply it. It almost certainly have to be in bottles, and then we're into bi-weekly wagon deliveries, complex permitry and operation of the site. So that was deemed unfeasible. But we did some great work to say yes, in the future this could be possible. With the right scale of boiler package that could be fed from hydrogen, and with a nearby supply, whether it's hard piped into the site or a very local sort of wagon delivery station, that is definitely feasible. So yeah, hopefully, I know I've waffled on probably a little bit there, but hopefully that gives some insight into where we are.
I think Chris, Zach and Nathan, what would be good is actually if we track this project. So we've got it now at this stage, and what you're presenting, what potentially those through design those benefits could be. We'll come back in and do a webinar maybe 4 or 5 months time, and let's just track this project through its life and look at what we've actually realized and the lessons learned. I think it'll be the lessons learned that'll be really key for everybody as we go through it. So it'd be quite nice to track the life of this project as we go. So another question here in the chat we got from Stuart MacArthur. Where do you get the embodied carbon data for your calculator? Nathan.
We've probably talked about two calculators there. So Zach used a calculation tool as part of the Burwell project, and we've got the Murphy calculator itself. So I'll talk about the Murphy one first. Basically, it's the vast majority of the data in the calculator is the usual sources that is available. So there's the ICE database, there's iStruct iStruct and others, and it's all pulled together into one overall database. To be honest with you, we've got a company supporting us to do that. The company that helped us develop the tool in the first place. So they're helping us, Action Sustainability, they're called, to maintain that database over time, and they'll make sure that if there are any new materials that can be added to the database, they'll keep updating that for us on a yearly basis. But it shouldn't stop you from going out and using the information, because there is lots of freely available data available. Sorry, Zach, if you want to talk about one.
Yeah. So yeah, with the actual life cycle assessment that was done for Burwell, so we used a tool from this company called One-Click LCA. So they've developed a cloud-based service where you can input all of your material data, or your operational energy consumption, your construction activities, and it would pull all the information in order to quantify the emissions based off of environmental product declarations. So these are like documents which are essentially mini versions of life cycle assessments for specific products. So the vendor would produce these documents where they would look into, all the different aspects, all the life cycle stages of producing their product, and that then forms a document which is uploaded to One-Click's database, and it draws figures from there. So that's quite specific on the product itself, and usually at a feasibility stage, you typically use more local averages. But One-Click itself has a bunch of different, it's got so many data points that it's pulling information from in order to create these averages. And then the intention is that as the design progresses, you then start to select, actually select your products and use environmental product declarations and the accuracy of the emissions increase as you use more specific product data.
Perfect, thank you, Zach. I think what would be useful as well is we've all kind of noted a number of different organisations within our sort of supply chain that we've used. So we can provide links to those for anybody else that might want to go and do your own research and have a look at what's out there in the market for your own operations and use. So that's it in terms of questions that have come through in the chat. Is there any other questions that people want to sort of raise a hand and speak up and ask on the call? Or any more in the chat, please feel free to drop them in. Likewise, if you don't want to put a question in the chat, or you don't want to speak up on the webinar itself, then you can feed them through actually to the guild, and then Kate will disseminate them out to us, and we'll provide a response back to you directly and for everybody else to see. Looks like we're probably drawing to a close there in terms of questions. There's no further questions, so everyone can have 7 minutes back and transition before your next team's meeting. I'm sure you've all got at 1 o'clock. So I think just to round up, really appreciate you taking time out of your busy packed schedules to join us, listen to our first webinar. Any feedback would be welcomed. You've seen the other lenses that we're going to be focusing on. If there's any specific topics in those lenses that you would like us as a panel to take away, discuss, you'd like to get involved, or even come down and join the panel or a roundtable discussion, please reach out to the guild. We'd love to have you involved in what we're discussing and what we're sharing in the communities we're creating. So I think to that point, I think we'll end. Thank you everyone in terms of Zach, Nathan, Chris and Hannah for the material and presenting and your time. Really good presentations. I hope everybody found it insightful, useful, and some and some thought-provoking information and detail you can take away and apply in your own operations and businesses. So to that end, have a lovely afternoon. Thank you for joining, and we'll see you soon.
Thanks, Adam. Cheers.
Thank you.
Thanks, all.
Thank you. Thanks all. Bye-bye.